Hello, welcome back to this channel. So I've come up with a new question. This question appeared in JEE Main 2020, the September season. So let alpha greater than 0, beta greater than 0 be such that alpha cube plus beta square is equal to 4 if the maximum value of the term independent of x in the binomial expansion of alpha x raised to 1 by 9 plus beta x raised to minus 1 by 6 whole raised to 10 is 10k, then k is equal to, okay. So the question has two parts, right? Of course, one part of the question, given a binomial expansion, given a binomial expression, finding the term independent of x is a very common question. Okay, that is one part. And of course, you're going to get the answer in terms of alpha and beta. Now it is given that alpha cube plus beta square is going to be 4. This is going to be a function of both alpha and beta. You have to find the maximum value of this expression. Maximum value of this expression. So that is the question. Let's see how this can be done. Let's see how this can be done. Of course, we have to do the first part. First part involves simple basic idea from binomial theorem. The second part involves some idea from calculus. Okay, because it talks about maximum value, right? Okay, cool. So let's see how this can be done. So we have alpha x power 1 by 9 plus beta x power minus 1 by 6 whole power 10. Okay, if you take a plus b whole raised to n, any term in this expansion will be of the form NCR a raised to n minus r b power r. And similarly, any term in the expansion of this expression will be of the form 10CR alpha x power 1 by 9 raised to 10 minus r into beta x power minus 1 by 6 whole power 10. Okay, so I'm going to separate the constant term, okay, the coefficient, and I'm going to separate the variable part, the power of x. Okay, so let's see. So we have 10 CR here, then alpha is raised to power of 10 minus r, beta is raised to, there is a mistake here, it's not 10, it's r. Beta is raised to the power of r. Now it is going to be x power 10 minus r by 9 into x power minus r by 6. And if this turns out to be the constant term, sometimes it will say the constant term, sometimes they may say the term independent of x, sometimes they may say the term with x power 0. Okay, so whatever it is, this is going to be k x power 0. Now you're just comparing what and what. You can compare the x part. Okay, these two parts can be compared. Of course, similarly, these two parts can be compared. Good. So now you have, let's see, we have 10 minus r by 9 minus r by 6 is going to be the power of x. So that has to be equal to 0. So we have 10 minus r by 9 is equal to r by 6. So you cancel 3. Here it becomes 2. This becomes 3. We have 20 minus 2r is equal to 3r. And r value comes out to be 4. R value comes out to be 4. R value comes out to be 4. Okay, so this part is straightforward, but I'll also give you a shortcut because this is a very common question. So it is better to actually skip all this step and arrive at the value of r directly. So I'll give you a shortcut for that. So if you have a binomial expression, just like in the question, if you have some alpha x power p plus some beta x power q whole raised to n, and if they are asked to find the coefficient of x power 0, or if you are asked to find the term containing x bar 0, the r value corresponding to the term will be np divided by p minus q. np divided by p minus q. np divided by p minus q will be the r value corresponding to that term. Okay, so it is better to memorize this because it's a very frequent question. So it has become very common. Now they have taken it to the next level. They have added one more part to that problem and made it much more lengthier. It's not complicated, but it has become lengthier. So it is always better to be aware of such sneaky shortcuts. Of course, if you cannot memorize it, don't bother about it. But if you can memorize it, it's well and good. But if you cannot memorize it, don't bother. Because if you make a small mistake, instead of p if you write q, or instead of p minus q if you write p plus q, whatever can happen, right? If you make a mistake, then gone. So don't blindly memorize it. Try to derive this expression, then memorize it and keep using it in the problems. Keep practicing it, then you will be able to remember it. Okay, so let's see in the question. In this question, we have P is 1 by 9, Q is minus 1 by 6, N is 10. So R comes out to be, this is P is 1 by 9, okay? Again, 1 by 9. So the answer comes out to be, this is NP divided by P minus Q. So it comes out as 10 into 1 by 9 divided by 1 by 9 plus 1 by 6. Simplify this expression. So this becomes 10 by 9 times, this is going to be 15 divided by 9 into 6. So 9 into 6 divided by 15. So 9 goes away. We have 60 divided by 15, 4. Again, 4 is the answer we got. So we got the same number as the answer in the regular way as well, the standard procedure. Okay. Now you go back and substitute the value of r to get the value of k, the coefficient. Where was our coefficient? No, this was our coefficient. K was equated as this number. So our coefficient is going to be, k is going to be 10c4 into alpha power 10 minus r, alpha power 10 minus r. So that is going to be alpha power 6 and beta power 4. And we are not done, because once you got this expression, we are supposed to find the maximum value of this expression in terms of, such that some constraint is given. Some constraint is given in the question, and that constraint talks about alpha cube plus beta square being 4. Okay, alpha cube. So let's see that expression again. It is 10c4. Okay, so we have got our k as 10c4 into alpha power 6 into beta power 4. Of course, this is a constant. This is a constant. So you don't have to worry about that. You just need to look at this expression. Alpha power 6 into beta power 4. Okay. So I'll give you several approaches to tackle this part. The first method is straightforward. You apply calculus. How will you apply calculus? You know that alpha cube is 4 minus beta square. So alpha cube can be replaced by 4 minus beta square. So this expression, I'm not considering the constant, okay? This expression becomes 4 minus beta square, the whole squared into beta power 4. This expression is alpha power 6 into beta power 4. So alpha cube was replaced as 4 minus beta square. So 4 minus beta square the whole square, because it's alpha power 6 and we have alpha cube from here. Okay. So this comes out to be 16 minus 8 beta square plus beta power 4 into beta power 4. So we have a function of beta which is beta power 8 minus 8 beta raised to 6 plus 16 beta raised to 4. Now to find the maximum or minimum value of this expression, you have to, of course there is some constraint also given on alpha and beta, that should also be noted. Alpha is greater than 0, beta is greater than 0. Okay, now this is an expression in beta and we are looking for the maximum value of this expression as beta varies. Okay, under this restriction beta is greater than 0. We have eliminated alpha. Okay, otherwise we have to worry about two variables. Using this constraint, we have eliminated alpha. Now our objective function, this is the objective function which needs to be maximized or minimized. Our objective function has only one variable beta. Look at this expression. So if I call this f of beta, we just differentiate and equate this to 0. Equate this to 0, differentiate and equate this to 0. So we have 8 beta raised to 7 minus 48 beta raised to 5 plus 64 beta cube is equal to 0. Of course, 8 beta cube can be cancelled off because beta cannot be 0. Beta cannot be 0, so 8 beta cube can be cancelled off. So we have beta power 4 minus 6 beta raised to, beta cube is cancelled, so we have beta square plus here 8 is equal to 0. So this can be easily factorized. So if I factorize this, this becomes beta square minus 2 into beta square minus 4 is equal to 0. We have two possibilities. We have beta square is equal to 2 and beta square is equal to 4. When you have beta square is equal to 4, what happens? Beta square is equal to 4. What happens? Alpha cube becomes 0 and this expression is going to become 0. So that will take the minimum value. Anyway, it is given that they cannot be 0. It is given that they cannot be 0. So this value we cannot take. Now, without worrying about the double derivative and all, we can directly take beta square is equal to 2. Without worrying about double derivative and all, we can directly take beta square is equal to 2 because the expression, there is no beta involved, just beta square is involved. Okay, of course we have two values from here. What? Beta is equal to root 2 and beta is equal to minus root 2. So you must be wondering which one will give the maximum, which one will give the minimum. Do not worry about that because question talks about only the maximum value and the expression will remain the same for beta is equal to root 2 or beta is equal to minus root 2. So there is this value will definitely correspond to the maximum value. So I'm going to put beta square is equal to, and we have already seen that the minimum value was 0 anyway. Minimum value was when beta square is equal to 4. Okay. But that will not happen in this particular question. They have restricted in such a way that this function cannot become 0. So don't worry about that. Okay. You can just take beta square is equal to 2. So when beta square is equal to 2, your alpha cube value is going to be 2. So this value is 2 square. This value is 2 square. So this is 16. This is 16. So that was one way to maximize that expression. Another way is let's see. We have alpha cube plus beta square is equal to it is given to be 4. Okay, and the question talks about alpha raised to 6 into beta power 4. Now I'm going to do a very ingenious method, and that is our AMGM inequality. How do we know that we can use AMGM inequality? First of all, in AMGM inequality, we have two positive numbers, A and B, and A plus B by 2 is greater than or equal to root AB. A is positive, B is positive. Now, how do you spot that AMGM inequality can be applied in this question? There are several things to observe. One is, question talks about only about positive numbers. Okay, the expressions we have are positive numbers. The expressions we have are all, when evaluated, will give you positive numbers. That is one thing to note. Secondly, the question talks about a maximum value. So there is some kind of inequality involved. Okay. Thirdly, we have a sum and we need a product. So three things I told you. We are dealing with positive numbers and we are searching for an inequality. We have a sum and we are looking for a product. Perfectly matches with your AMGM inequality concept. So I'm going to use that. Okay. So I'm going to use AMGM inequality in such a way that it suits my purpose. Okay. So it is a tricky thing. So this intuition comes through practice. Okay. I mean, there is no general rule to use this, when to use inequality and how to use this. These things will come only through practice. So observe that I need to get alpha power 6 and beta power 4. So what I'm going to use is, I'm going to write this expression as alpha cube divided by 2 plus alpha cube divided by 2 plus beta square divided by 2 plus beta square divided by 2. This expression can be written in this way. This will be greater than or equal to, use alpha cube by 2 into alpha cube by 2 into beta square by 2 into beta square by 2. So what does that give me? So if I call this P my product, if I call this P as my product, so this expression is exactly 4. I forgot to write 1 by 4 here. Okay, I'm sorry. For four numbers, the AMGM inequality will be in this form: x1 plus x2 plus x3 plus x4 divided by 4 will be greater than or equal to x1 into x2 into x3 into x4 raised to 1 by 4. For positive numbers, for positive numbers, the AMGM inequality will look like this. So this becomes, we have alpha power 6, alpha power, so we have 4 greater than or equal to P by 16 raised to 1 by 4. Right? So we have alpha cube and alpha cube is alpha power 6, beta power 4, that is nothing but P divided by, we have 2 power 4, that is 16. Did we mess up somewhere? Because our answer should have been 16. We have alpha cube by 2, beta square by 2, beta square by 2. I have missed a 4 here. Okay. I'm sorry, I have missed a 4 here. See, I have missed a 4 here. Just like I missed a 1 by 4 here. I missed a 4 here. So this will be 1. This will be 4 divided by 4. Okay, this will be 4 divided by 4. Now, you have something of this form. You have 1 greater than or equal to P power 1 by 4 divided by 2. So your P power 1 by 4 is less than or equal to 2. Your P is less than or equal to 2 power 16. 2 power 4, which is 16. 16. So that is another way to arrive at the maximum value of that expression. Okay. So what first method was calculus, second method was AMGM inequality. There is one more way. Okay. If you have very good observation, there is a very easy way to arrive at the answer. Okay. So here we have sum of two numbers is equal to 4. Sum of two positive numbers is given to be 4. And you know that its product will be maximum when they are equal. You already, if you already know this funda, sum of two numbers is a constant. Their product will be maximum when these two numbers are equal. Okay, so equal means this will be 2, this will be 2, this will be 2, this will be 2. Okay, so alpha cube into beta square will be maximum when this is 2, this is 2, which is 4, maximum. And our p was nothing but the square of this quantity, which was alpha power 6 into beta power 4, which is 16. The maximum value was 16. Cool. So just by direct observation, you can simply arrive at the answer. So combining two shortcuts. The one shortcut was for the value of r. The second shortcut is for finding the maximum value of this expression. You can actually solve this question in less than 2 minutes. Okay. Just like in the previous one of the previous question. If you know these two shortcuts, you can actually do it in less than 2 minutes. Now let's find the final answer, because in a final answer you need to have 10c4 into 16. So 10c4 will be 10 into 9 into 8 into 7 divided by 24 into 16. So this is 3 here, and this is 3. Hold on. We got 10c4 into alpha power 6 into beta power 4, right? We have 16 into 10c4. Yeah. So this will be 10 into 9 into 8 into 7 divided by... Oh, okay. Oh, it is given to be 10k. Okay. So you have to find the value of k. It is given to be 10k. So you don't have to worry about the 10 there. Okay. So this is given to be 10k. This is given to be 10k. It's not k, it is given to be 10k. Okay. So 10k is, so 10 goes away. Your k value, the required answer will be 21 into 16. 21 into 16. So that will be 21, 16 into 21 will be 16, 32, 336. I hope we have an answer. Yes, 336 is the right answer. Yes, I have discussed several things, but during an exam, you don't know which method will strike you. So you should be aware of all these methods, all these approaches, all these ideas, all these concepts. Because if you have sufficient practice, if your concepts are very clear, okay, when you look at the question, when you look at the options, if you have very good observation, you will be able to spot you'll be able to arrive at the answer in maybe 2 or 3 minutes using the appropriate tricks. So I'm going to wind up here. If you like this video, please do let me know. If you have any suggestions, if you have any queries, please do let me know in the comments. I may not be able to reply to all of your comments because I don't spend time replying to the comments. I don't have that kind of a time, but I'll be definitely reading the comments. So please do let me know. Okay, thank you. See you in the next video.